Now we're going to combine this for rotating around the y-axis. And so it's the same formula, and just kind of everything's flipped. So the only thing different, we're going to be rotating this direction around the y-axis instead of this direction around the x-axis. And this is our volume. So on this next one, we're given y is equal to natural log x. 1 is less than x is less than e. Okay, so we're going to plug it in. Pi, we need to find the inverse of natural log of x. That's pretty simple because we just take the e of both sides, and so it's e to the y. So e to the y squared dy. Now we also need to transform this into y values, and so when x equals 1, if we plug in 1 to the original, so y equals natural log of x. If we plug in a 1 here, we're going to get y equals natural log of 1, which is 0. And then if we plug in an e, y equals natural log of e, those cancel and leave a 1. And so this is the volume equation we want to use. So I'm going to just say 2y, distribute that in there, and then we get e to the 2y when we take the antiderivative, and then 1/2, and we will evaluate that from 0 to 1. So we get pi 1/2 e to the 2 times 1 minus 1/2 e to the 2 times 0. Okay, that's just a 2, so it's e squared. So we get e squared over 2. Still got our pi out here. That's just 0. E to the 0 is 1, so minus 1/2. And we can factor out a 1/2, so we can say pi halves e squared minus 1 units cubed. Okay. Now, volume, if we're doing some rotations, but we have maybe like a hole in the middle. So basically it's just like the area between two curves formula mixed with our rotation, our revolution formula. So once again, we're just going to go from A to B. Then we're going to have f of x quantity squared minus g of x quantity squared dx. And remember that this is the upper function and this is the lower function. So now it says find the volume of revolution generated by the revolving region between y equals x squared and y equals the square root of x. Okay, so when we're setting those up, we want to know which one's on top and which one's on bottom. So y equals x looks like this. So that one, and then this one is going to look like this. And so the green is going to be the upper, and this is going to be the lower. So when we're doing that, so this is like f of x, and this is g of x in our formula. We also need to know where they intersect. So we can see that they intersect at the origin, and so we just need the x value. So that's going to be 0 down there, and the value where they intersect right there is going to be 1, because if we plug in 1 here and 1 here, we'll end up with the same answer. Now we plug in square root of x squared, that's our upper, minus x squared squared, that's our lower, and then we have dx, and then we have our pi out in front. Okay, now when we simplify that, we just get x, simplify that, x to the 4th, and now we need to take the antiderivative, so it's going to be x squared with 1/2 out in front. This is going to be x to the 5th this 1/5 out in front. And then we have pi, and we go from 0 to 1. Alright, so moving that over here, we have pi. I'm going to plug in a 1 first, so 1/2, 1 squared minus 1/5, 1 to the 5th. Trying to think what kind of brackets to do. Okay, then we'll do that. Then plugging in a 0, it's 1/2, 0 squared minus 1/5, 0 to the 5th. Okay, this is just 0, this is just 0, so none of this matters. This is just a 1, so 1 times 1/2 is 1/2. This is just a 1. 1 times negative 1/5 is negative 1/5. Okay, now we just need common denominators. So this is 5 over 5. This is 2 over 2. So we get 5/10 minus 2/10. Minus those, it's 3/10. So we get 3 pi-10ths units cubed. If you need additional help, please come to MathLab. Until then, calculator.